a wash basin is
This meeting is being publicly streamed.
okay. Yes. Correct. A washing basin has an exit pipe covered with a plug area of 12 square centimeter. A chain is attached to the center of the plug to assist in pulling the plug away from the exit hole. The wash basin contains the water depth of 0.08 meter. Okay, this is area, this is depth, so I can write it H. The density of the water is this much, so you have written the density, or you have density as well. What is the force acting on the plug due to the water? Okay, this is the question. So the solution of this question is, you have to figure out the force acting at this point, right? So force is basically, force is equals to pressure times area, and that pressure is equals to liquid pressure kya hota hai, rho gh into area. And if you have the density 1000 into value of g is 9.8 and height is how much? 0.08. I need calculator support. Okay, and area is 12 square centimeter. So 12 into 10 raised power minus 4. This is basically the conversion of area. Okay, let me calculate. Meanwhile, any one of you please calculate, and let me convert this for you. For area, 1 centimeter is equals to 1 by 100 meter, or it can be written as 10 power minus 2 meter. Is it clear to everyone?
Yes, sir.
Okay, then this, if it is 1 centimeter square, it means that this is 10 power minus 2 whole square. So that proves that 1 centimeter square is equals to 10 power minus 4 meter square. Is this clear to everyone? Yes, Muhammad, Ibrahim, Raid, Ariba. Is it clear to all of you?
Yes, sir.
Yes,
Okay,
sir.
Yes,
good.
sir.
So what was the answer? Calculations, please.
So 0.9408.
0.
9408.
Yes, 0.9409, which is almost closer to 0.96 Newton, because rest all are not closer to that. That is why this is the force. Okay, is it clear to everyone? Danji, the next question is that the volume of the gas is measured by the different pressures. Okay, the pressure of the gas and volume is found to be related by this equation PV equals to constant. And I told you that this P and V equals to constant mean that once you are increasing the pressure, volume will be decreased, and if you are decreasing the pressure, volume is increased, and so on. So during this all, right, which quantities are kept constant and which quantities are changed? Yes, so here, which quantities are changed? Density of the gas, mass of the gas, and temperature of the gas. So density, you are not sure about the density, but you are sure about two things: that mass will not change and temperature of the gas does not change. So you have to hunt two ticks, right? For density, I can make you clear that, for example, when the pressure would be decreased, when the pressure will increase, then density will decrease, molecules will get closer. Okay, and when pressure will increase, when pressure will decrease, molecules will get apart. That is why density will not remain same. So two things will remain same: mass of the gas and temperature of the gas. So density is not constant. That is why it is this. Okay, clear? Clear? Then question number 3, the equation used to find the pressure caused by the liquid is density is equal to dash into dash, yani H into Y into Z. So what are those two values? H into rho into G. Is it?
Yes, sir.
Got it. So what should I write about this?
D.
Good. So B will be the right option. तो ये नट का इशू है. Tohid, are you there? बेटा अभी तक माइक नहीं सही हो तुम्हारा. क्या करते हो यार, माइक ऑन रखा करो बेटा, इस तरह क्वेश्चनिंग क्रॉस क्वेश्चनिंग नहीं हो पाती. ओके सो हाइट, ठीक है मैं क्लास के बाद डिस्कस करते हैं इस टॉपिक पे. द डेंसिटी एंड ग्रेविटेशनल फील्ड स्ट्रेंथ, राइट? सो दिस इज डेंसिटी, gravitational field and this density, so option D would be the right option. The next question is, a gas is sealed in a container, is compressed at the constant temperature. Which graph shows how the pressure of the gas changes with volume? So pressure and volume are inversely proportional. I told you about that. This is very common point. So D is the right option. Okay. Then container is filled with a liquid to to a certain depth. The pressure of the liquid at the bottom of the container depends upon the several factors. Which of the following factors does not depend upon? Right? You have to figure out those. So you know that pressure is equals to rho, G, and H. So whichever is not here, you will exclude that. So G is here, density is there, depth is there. The strength of the magnetic field is not here. So this is the right option. You got the point? Is it clear to everyone?
Yes, sir.
Okay. The position of, okay, yeah, this was the question. The diagram shows the gas that is trapped in a cylinder by a piston. The volume of the gas is 120 cubic centimeter and the pressure of the gas is P. Right? The piston is moved slowly to the left so that the volume of the gas is reduced to 30 cubic centimeter. The temperature of the gas does not change. Remember, the temperature is not changed. What is the pressure of the trapped gas? So, do you know what is the equation? P1 V1 equals to P2 V2. That is the solution. So, what is P1? P1 is P. And what is V1? V1 is given by 120. So, V1 is 120. So, P2 is unknown. And what is V2? V2 is 30. So, what will be P2? P2 will be P into 120 divided by 30. So it means that it is 4 times P, right? So that is the right option. D is the right option. What is the pressure? Pressure is 4 times the new pressure. Sorry, the original pressure. Is it clear? Got the point? Then we have this diagram, that the diagram shows the holding back water. Okay, 65 meter is the depth of the water and there is a dam. So the density of water is 1000 kg per cubic meter and the value of G is taken to be 10. So what is the pressure? So it's quite easy question. Pressure is rho G H and that gives you 1000 times 10 times 65. So 65 will take 4 zeros with it. 65 will take 4 zeros with it. So this is the right option. Then you have this question. This is again the pressure volume. This is a pressure, and this is a question of the pressure of the gases. The air is trapped in the cylinder by a piston. The original volume of the is V, and original pressure is P. Okay, the piston is pushed to the left. To the left. Yani pushed to the left means volume has been reduced. Okay, and temperature of the gas has no change. What is the new volume that? Sorry, what is the new volume and what is the new pressure of the trapped air? So did you notice it is V1 is 50? Am I right? So what is V2? 25. So V2 is halved. If V2 is half, what about the pressure? Pressure will be double, na? Because the trick is if V2 is half of V1, P2 will be twice of V1. Is this clear? So new pressure is V by 2 and new volume is V by 2 and new pressure is 2P. So is this clear? Okay, there is a trick for this question. Everyone clear now? The trick for the question is just multiply both the columns, right? Multiply both the columns and your answer should be equals to PV, right? Yani 2P into V, what will be the right answer? PV. What will be the right answer here? 4P. What will be the right answer here? PV by 4, right? What will be the right answer? PV. Now you will be trapped in option A and option D, because in option A and option D, both are giving you that pressure and volume product is always constant. But here the logic tells you that your volume has been reduced. That is why this will be discarded and D will be selected. Okay. The next question is a logical question. And in this question, the gas of a container and the temperature is in the container, the fixed volume, the gas is exerted to the pressure of the wall of the container. The pressure is caused by the gas or the molecules striking the wall. Which statement about the gas molecules when they strike with the walls is correct? Right, the average kinetic energy of the gas molecules changes, the average momentum of the gas molecules changes, the average speed of the gas molecules changes, the chemical energy of the. Yes, Mehmet, what did you write about this?
Sir, my answer is B. The average momentum of the gas molecule changes.
Yes, Ariba, the same for you or not?
Yes,
Tohid.
sir. It's same.
Yes, so Tohid, what was your answer? Okay, so yes, it would give you option B, because momentum of the gas molecules changes. Now this is question number 10, and then along with that question number 11. Question number 10 is that yes, the diagram shows the different containers J, K, and L. Each container contains the water at the same depth. At the same depth, which statement about the pressure of the water on the base of each container is correct? Yes. If the depth is same, they are of the same liquid, right? Each container the water, definitely water is there. So will should there be the pressure same or not?
No, sir.
No. Actually, this is a trappy question. So pressure is equals to pressure of the liquid is equals to rho gh. So none of the factor or none of the variable is different, right? They have same density of the liquid, same value of the same depth, so they will have the same pressure. You got it? This was basically a trap in this question. The next is the pressure volume. Yes, some gas is trapped in a container, a fixed volume. The temperature of the gas increases. Temperature of the gas increases. Yes. Which graph shows the pressure of the gas changes with temperature? So as pressure increases, temperature increases, or as temperature increases, pressure increases. So which graph would be the right option? D. Okay, because here it shows that pressure is yani pressure and temperature are not directly proportional to each other, yani they do not change with each other. Here it says that pressure as temperature increases, pressure decreases, which is false. Here, as pressure increases, temperature decreases, which will also fall. So as pressure increases, temperature increases, this is the true. Okay. Okay, Ji?
Okay, sir.
Okay, the next one is this. Yeah, now we are talking about the theory parts. Just give me a second, and I'm just sending a message to my AS class. Okay, so here we go. Yeah, this question was related to the pressure. If you have a thumbnail, thumb pin, and you are going to put that thumb pin, yeah, you are going to apply some force on that. So where the pin has head over here and pin has basically tip, right? So these there are two class at 7. Just sorry. And one more thing, yeah, sorry for inconvenience. You people, I don't know, you people have not got the updated time. Your class, I have put your class on Friday and Saturday also. If you people are available, then please join me. Okay? I tried my best कि हम लोग maximum time ले सकें. So on the weekends, if you people are free, especially Friday, don't miss Friday class. Okay, Saturday, yes, you people can be here and there. On that day, recording can be working. But on Friday, there will be a fixed class at the same time. So please join it. Okay.
Okay, sir.
Okay, sir.
Yes. And that will be basically a long class. I will try my best to discuss some worksheets and those topicals in the Friday's class so that we can um, practice during the class also, because during class practice is least from our side, because now I have a full-fledged focus to complete the syllabus, but that makes me a little bit, you know, deficit on the practice side. So I entirely depends upon your contribution in the practice, but I believe that there would be some issues. So I will try to manage those issues. Okay. A man squeezes a pin between his thumb and the finger. As soon as we get the finger exerts 84 Newton force on the pin head. Okay, 84 Newton. The pin head has the area of 6 into 10 raised power minus 5 square meter. Calculate the pressure exerted by the finger on the pin head. So what will be the pressure on the thumb pin? Yes. What is the pressure? So pressure will be basically pressure is equals to force upon area, and force upon area means 84 Newton is a force divided by area is 6.0 into 10 raised power minus 5. Yes, Ariba, what is the answer?
Sir, 14 and then 5 times 0.
14, 1, 2, 3, 4, 5 zeros. So it would be written 1.4 into 10 raised power 6, and unit will be Pascal. Okay, are you getting this thing? Is this clear to everyone?
Clear,
Yes.
sir.
Yes. State the value of force. Now this is state the value of force exerted by the pin on the thumb. So how much force is being exerted by thumb on pin on the thumb? So you know there is an action force downward, and as a result there will be a reaction force on the thumb. Sorry, on the finger or on the thumb? Sorry. On the thumb. So this will happen. Yes, it is exerting a force downward. So both the forces will be equal and opposite. You got it? Because of action and reaction. And remember one thing, force does not change, only pressure changes. So that is 84 Newton. Explain why the pin causes more pain on the man's thumb than that of the finger. Yes, what is the reason?
Because the pin has small area, so it will exert large pressure.
Very good. Are you people agreed with Ariba's answer? Everyone?
Yes.
Yes, sir.
Very good. So, due to smaller area, more pressure will be exerted. So that more pain. Okay? In the thumb. Got it? Next, the density of the water in a swimming pool is 1000 kg per cubic meter. The pool is 3 meter deep. Calculate the pressure of the water at the bottom of the pool. So what will be the value? So pressure will be equals to rho gh, and pressure is density is 1000 into 9.8 into height is 3. Yes, what was the answer?
29,400 Pascal.
29,400 Pascal. So that means you will write 29,000 Pascal as a rounding off, because you have two significant figures maximum value. The another pool has the same depth
So
of the.
do we have to round it?
Yes, we are going to round it off because here we have only one significant figure, here we have only one significant figure. So our answer can be more than one more than the significant figure in the data. Maximum, not more than that. So if it would be 29,500, so I would love to write it 30. Okay? Is it clear?
Yes, sir.
Okay. Another pool has the same depth, but the twice of the area. Twice of the area. State the pressure of the water at the bottom of the pool. Oh, 1 mark.
Say 29,400.
Yes, 29,000 Pascal. The reason you can, if it would be a logical question, then it would be more practical, right? Why? Because pressure does not depend upon the area. Liquid pressure does not depend upon the area. Don't write only pressure. The liquid pressure does not depend upon area. Is it clear to everyone? Okay. The next is basically this was the more practical question. Figure 4.1, designed to remotely operating electrical switch using a pressure. Right. This is the electrical switch operated by air pressure. Then you have the connecting pipe, flexible rubber, and box cover, right? Metal box, etc., etc. The metal box and the pipe contains air at the normal atmospheric pressure and switches off. When the pressure in the metal box and the pipe raised 1.5 times atmospheric pressure by by pressing down on the flexible rubber box cover, the switch comes on. Wow. Explain in terms of the pressure and volume how the switch is made to come on. How the switch is made to come in. How the switch is made to come on. Yes. So once you will increase the pressure here, what will happen?
So the volume of the air is compressed, increasing the pressure.
Yes. And that gas will travel through the pipe, and when it will travel through the pipe, it will try to increase the yani volume is increased. Actually we are going to decrease the volume now. What we are going to do here, by pressing, the volume is decreased. When volume is decreased, here pressure is increased, and when pressure is increased, it operates the switch. Okay. Electrical switch which is operated by the pressure. So you can simply write that as it is set. Sorry, when the pressure in the metal box is raised to 1.5. Okay. Yes. As the let me explain you answer. As the pressure increased, then what happened?
The volume of the air is compressed.
Yes. Volume is decreased. Yani air is compressed. Air is compressed and the switch is operated. Our switch is closed when low, or when the volume of the when volume of air decreases in pipe. Decreases in pipe. Yani here the volume will be decreased. Sorry, I have just put the in reverse. So this is the switch. So when volume will be decreased, it would be closed. Then it would be operated. Normal atmospheric pressure is 1.0 in 10 to the power 5 Pascal. Okay. At this pressure, the volume of the box and the pipe is 60 cubic centimeter. Calculate the reduction in the volume that must occur for the switch to be on. Okay. So first of all, we have to calculate. We have to apply P1 V1 equals to P2 V2. Right. This is the formula. And when this is applied, this is found. Then you have to find the second in any volume in the next time. Volume 2 is P1 V1 divided by P2, and that will give you that what was the pressure, atmospheric pressure 1.0 into 10 raised power 5, and what was the initial volume? It was 30 cubic centimeter. It was given there. No,
60.
60 cubic centimeter. Yeah, 60 cubic centimeter. Yeah, it is written here. 60 cubic centimeter divided by, no need to convert it because we will write the volume in the cubic centimeter. The pressure one is 1.5 times. So you will write 1.5 into 1.0 into 10 raised power 5. Right? This is basically the entire value. So just please give me the calculations. What is the new
Sure,
volume? 45 cubic centimeter. So reduction is change in volume, and that is 60 minus 45.
Sure, 40, not 45.
Okay, okay, okay. 40 पानी लेके आओ यार सारे. 40. Okay, so that is 20 cubic centimeter. Okay, is it clear to everyone? Okay,
Yes,
the
sir.
explain in terms of the, yes, any question?
No, sir. I just said it's clear.
Okay, good. Explain in terms of the particles why the switch may operate without the rubber cover being squashed when there is a large rise in temperature. Yes. Good question.
So a large rise in temperature makes the particles move faster. They hit the walls more often with more force. This increases the pressure inside, hence the switch can be turned on.
Perfect. More, the molecules get more kinetic energy. Okay. The molecules get higher kinetic energy. They have more frequent collision. Okay. So they can cause more pressure. Yani, you can simply say that pressure is directly proportional to temperature. Yeah, as pressure increases, sorry, as temperature increases, pressure will increase. You got the point? Is it clear to everyone? Yes. The last question, question number 3, I will try to finish it up as quick as possible because next class is ahead. The photograph shows two containers that store the rainwater. The containers have taps, that the taps are closed. Taps are closed. I think there was something. Just yeah, maybe it is hidden. The diagram shows the water levels inside the container, right? Water levels inside the container. This is a big 19 centimeter high, 34 centimeter, 91 centimeter high, and then this is 34 centimeter high. The density of the water is this. State the equation that links pressure difference, height, and this all. So it will be rho, G, and H. Calculate the pressure of the water caused by the at the base of the container A. So it would be again rho, G, and H. So you will plug in the values. 90, sorry, 1000, 1000 into 9.8 into 91 centimeter is basically 0.91 meter. Yes. So what's the answer?
8918.
8918, which is basically 8 9 sorry 8900 Pascal. Got it? Is it clear to everyone? The
Yes.
next is when the taps are open, the water flows into the pipe for some time. I think so. The final water level in container A. I think there was something missing. So sorry. I just changed the diagram position of this diagram. That made this problem here. Complete the diagram. Show the final water level in container B. Okay. And explain why the water starts flowing and stop then. Okay, I can give you the details of this because this is the diagram is not clear, so I will just leave this question and I will award you the marks. So here, when the pressure in both the containers, when pressure in both containers, सारी में पानी नहीं यार, त्रे लगी नहीं. Both containers are equal, then no more transfer of water takes place. Okay, got it? Clear ji? So this was basically the test. So I have solved it here. I'm gonna send it to you. Now you can evaluate even yourself that yes, how much marks will I get? So everyone has a task. Recheck your paper, evaluate yourself, and tell me your score. Meanwhile, I will check your score and I will let you know that whether we have the compatibility or not. Okay? Yes. Any question till this point?
No, sir.
Okay. See you then, inshallah.
Allah Hafiz, sir.
Allah Hafiz. Tomorrow, inshallah, at the same time, we will have the classes. So, see you